So last time I talked about kind of walked people through, I don't know how many of you were there in my talk about the history of AI, sort of my personal perspective from when AI was first named in 1956 to kind of up to the dawn of the generative AI, ChatGPT era, and so on. Today's talk kind of takes it forward into the at the leading edge, where now people are talking about going beyond just generative AI applications to really building autonomous AI agents. And the challenge that comes is that for these agents to be successful, they have to solve business problems that involve reasoning about the underlying domain. And if they're not going to be able to do that correctly, then these agents are basically going to give you the wrong answers, do wrong things. And the consequences of that are going to be, could be quite disastrous. So my talk is focused on one, why the agents actually don't reason correctly, and then some of the things that can be done, at least based on the work I've done. But there are a lot of other techniques which I wouldn't really have time to go over. But I hope this will give you guys the foundation to start digging into this some more. Um, the talk is actually quite long, but I'll kind of keep track of the time, and I'll try to end by 11, and then we'll go into questions. I've given Ramesh Bhai my full deck. Students are encouraged to go through that, and if something really catches their attention and they want to interact with me, my email address is there. Feel free to reach out to me, and if I can, I'll be happy to respond. So what are AI agents, right? I mean, I'm sure you all read every day about AI agent this, AI agent that. They're going to be built, and they're being built for doing all kinds of things. Foundationally, they're all built around LLMs, and I'll talk about the LLMs in more detail. But LLMs are the core technology behind generative AI, ChatGPT, Gemini, all these different chat programs that you hear about. So there are some key characteristics that are important when you talk about AI agents. One, they're conversational. What that means is that instead of interacting with them through the ways we have been interacting with computers and software for the last 30 years through user interfaces and point and click and menus and so on, you simply just describe in English what you want, or some other natural language, and they respond back in that same language, and the whole dialogue proceeds that way. So the whole idea is that you'll talk to these agents much as we talk to each other as human beings. The second part is that these agents are, for the problem and there are some dependency between the tasks. The tasks have to be successfully completed before you can go to the next one. And if something goes wrong, then there's a branch. So you get a bit of a branching logic, but at least to start with, they're relatively simple workflows. But of course, as the tasks get more complicated and the kinds of ways they can fail get more complicated, these workflows are going to start to get more and more diverse, complex, branching logic, all that kind of stuff. The third part is that it is not simply a matter of doing multiple steps, but many of these steps actually involve applying business logic. So what I'm going to do is I'm going to go through a few examples very quickly. But the logic could be, if you're filing an insurance claim, look at the details of what actually happened and what compensation you might be entitled to, or if you're applying for a loan, do you meet the underwriting criteria of the bank, and so on. So that logic needs to be applied correctly, because the thing that's interesting about these agents is that more and more they're going to be autonomous. What that means is you describe your problem, the agents go out, do their own thing, and come back with the answer. And down the line, they may even make a decision. So if you're talking about, let's say, an insurance application or a claim application, you just describe your problem, it goes ahead, makes a decision, and in the best case, you might simply get a decision saying yes or no, or you might even get a check showing up in your account which says, okay, we decided to cover your insurance claim by so many rupees or dollars or whatever, right? So the autonomy is very important, and you'll realize that the moment we start talking about the agents being autonomous, the fact that they could make mistakes actually have much larger consequences than if they were simply being used as assistants to human beings that are making the decisions. And people are already talking about not just autonomous individual agents, but agents talking to other agents. So it's like we there could literally be an army of agents in cyberspace that are doing various things, and they're talking to each other, and so the autonomy gets taken to the next level. Uh, to dive into this a little bit more, the business logic typically involves a variety of rules that dictate how decisions should be made, a number of constraints that kind of that restrict what things can and cannot be done. And there's a very simple, timely example. I mean, I think all of you have been reading what's happening with Indigo and their flight delays and so on. And it ultimately came down to Indigo not really applying the business logic correctly, because the Director General of Civil Aviation came out with new rules about you know and for whatever reason, the management at Indigo did not apply that correctly in terms of affecting their scheduling. And the result of that is that in the last 4 been a massive chaos and air traffic in India. And that's a very, very pertinent example of an organization making a mistake. Now, imagine if we actually had autonomous agents doing all of this work. This could have a worldwide impact where all the traffic in many, many countries could have been affected. And this happened only because its scope is narrowed only because it was still not being done in a very autonomous fashion. Anyway, then the solution to the business problem could simply be as you give a problem and you get an answer, or it could be a series of steps that have to be taken, and each step has to be correct. So it can be a single step or it could be a multiple step. uh, One of the hallmarks of intelligence that we all respect as human beings is that it's not important just to solve the problem, but we also have to be able to explain why you did that and how you did that. And that's important partly for raising the confidence. One of the important things for these agents is not only should they be able to solve the problem, but also give an explanation for multiple reasons, and we'll talk about that. Now, in terms of real world problems, there are a whole bunch of these, and I'll talk about EU travel as one example. And if I get time, we'll talk about agentic commerce, and then I'll use like a river crossing puzzle as a simple example that really dives deeper into challenges in solving a multi-step planning problem. Now, this business logic is not something that is restricted to any single domain. I mean, I've just listed uh, many different application areas that where people have been building software, then AI systems, and now agents, and they all involve you know variety of business logic. So in agentic commerce, uh, typically involves doing product search, and then maybe seeing applying any coupons or any discount policies, and then you make payments. And then of course, sometimes the customer is not happy, they return, and there are policies about what returns are acceptable in what time frame, and do you have to return the product or not return the product. So basically every single step in the enterprise involves some kind of logic that must be followed, and certain thing that must be done, and certain thing that might be optional. We'll dig into EU travel a little bit more detail. If you look at banking, there are money laundering, there is currency, there is know your customer, any investment product you buy, mutual fund, annuity, and so on. They all have all kinds of different rules and regulations, banking, government, and so on, that have to be followed. So basically, any enterprise, down to insurance, credit cards, government regulations, every government enterprise is governed by rules and regulations, policies that must be followed. So any attempt to build an agent would need to make sure that it is following all of that correctly and systematically. So let me do a quick digression into what are LLMs. Remember, I said all the agents are being built on top of these LLMs. I'm sure all of you have general understanding about what an LLM is, but I want to just review your key features because you have to understand that before we can talk about why they make mistakes. So an LLM is basically a very, very giant neural network. And the neural network is built by training the network on massive amounts of data. I mean, when I say massive, it really is massive. Currently, the largest model, let's say ChatGPT 5.1 or Gemini 3, they're built on practically the entire public internet. And it's very hard for us to sort of get a sense of that by just talking about it, but we're talking about terabytes of data. The first ChatGPT 3.0 that came out was built on top of, I think, about 50 gigabytes of data. And now we're talking about terabytes of data, which is many orders of magnitude more. Uh, Basically, anything that's available on the public internet has now been scooped up into building these models. So this giant neural network has built a big probabilistic network on if you see n words, what is the n plus 1th word that'll come next based on all the different sentences that have been processed, right? And it uses that network to then generate uh, new sentences. And since it is probabilistic and not fact-based, it can make mistakes, and we'll talk about that. And of course, the LLMs have now been augmented with not just text data, but multimodal to include images, video, music, DNA data, whatever. And so they've now become truly multimodal. And you can, I'm sure you've played with image generating chat programs where you can describe something in English and it'll actually draw a picture for you. So
Dr. Mittal, Dr. Mittal, are you showing the slides because we don't
oh,
see
I'm
it?
sorry. I'm sorry. I don't know. I should you should told me earlier. I got to share my screen.
Yeah.
1 second. I'm I'm really sorry. Earlier.
Yeah.
Can everyone see my screen?
Yes, yes. Can you make it a little larger? Is it possible?
Yeah, no, I'm going to make it larger. I'm going to go full.
Okay. Yeah, there we can see the screen. Yes. Thank you.
So,
And then my students are really, they have requested me earlier also, and I do in the other talks also. I, I actually translate the slides to Hindi. So I'll talk to you later after this if you will allow me to do that conversion of the
sure,
slides
sure.
to the student.
I've no problem. In fact, you might be able to use one of these chat programs to do that automatically.
Yes, yes, yeah. Okay, thank you.
So let me do the following thing. Let me quickly just walk through the slides that I already shown.
Yep,
So this is my title slide. AI agents are built around LLMs. Uh, the steps they have to follow to solve a problem. Uh, every enterprise application really involves the business logic that needs to be followed. So we covered that. What are LLMs? So I think this is the slide that I was on, right? Uh,
yep,
so a key part of the LLM architecture is something called a transformer. And so what the transformer does is you give it some input, and it systematically takes the words which have been tokenized in your input and generates a new output. And it generates a new output by using the LLM's deep neural network, probabilistic network to figure out the next word. So think of it like a very, very iterative loop. It starts with if I say, who is the Prime Minister of India? It'll take the words and one by one, it'll look at the next word from this network, then it'll feed it back into the network and then generate the next word. And it'll keep doing that till no change happens attention because it is paying attention to the words it is generating itself, right? There was a very fundamental paper that was done at Google called "Attention is All You Need," which gave rise to this whole transformer technology. Uh, So the since the underlying network is very probabilistic, the answer that you get can be very, very good, or it may be totally wrong, because it's only based on the probabilistic weights between these words. And even though it can take many words into account, it's not just doing one word and the next word. It can do two words followed by the third word, and then those three words followed by the fourth word. And so it iteratively builds the answer. And as it adds more and more words, the quality of the answer can get better and better. And in many cases, you will get the right answer. But in many other cases, you'll get the wrong answer, and I'll come to that. Uh, one of the key things that happens inside the transformer is it can generate the nth next probabilistic token. So let's say, if you have number of words you're looking at, and it's okay, what is the next word that follows? It doesn't always pick the highest probability word that comes next. It looks at the n highest probability word tokens, and sometimes will pick just one out of those n. And that means that you're not always picking the best answer, but based on experience, I think what they found is that if you always pick the highest probability token next, the answers you get end up looking very sterile and very restrictive. So deliberately, to create some variety and richness in the conversation, they pick often not the highest probability token, but that also means that the system can make mistakes more often. So why do LLMs hallucinate? And again, hallucinate is one of those anthropomorphic word, because obviously computers don't hallucinate, human beings hallucinate, but it has come to be kind of a quote unquote a word to represent the mistakes that LLMs make when they're generating answers. And the reason they hallucinate is they're designed to pick the next token, but they don't really have a notion of what the right answer is. So they're finding probabilistically, based on this massive amounts of data that they have processed, what is the most likely next word that should appear based on everything it has read about. But that doesn't necessarily mean that they'll give you the right answer. Uh, Oftentimes they're designed to basically generate some answer, but they have no notion of, do I know the answer or do I don't know the answer? There is no such notion. So they simply think of them as large glorified sentence completion machines. It's just that they've been trained on such a large amount of data that they often end up doing the right thing. So in some ways, hallucination is actually quite fundamental to how the transformer and the LLM actually produce the answer. And I think some of the work that I've done and other people have done shows that actually, if they didn't hallucinate, they will probably actually perform poorly. So it's kind of one of those uh, uh, you live by the sword, you die by the sword kind of a scenario. If they didn't hallucinate, they would not make mistake, but they would not even get the right answer. But because they hallucinate, they are able to look at lots of different possibilities, out of which many times the right answer comes, and in other case, you get the wrong answer. A lot of work has been done, which is kind of way beyond the scope of today's talk, in things like supervised fine tuning and RLHF, which stand for reinforcement learning human feedback, that is used to, once you build the initial foundation model, it goes through lots of training and refinement based on huge number of real world examples where uh, lots of smart people are used to do fine tuning and feedback to say, okay, on this problem, if you try this, you get this answer, which is the right answer, and it's used to then go back and revise the weight. So despite all of that, the fact that the network is probabilistic, and it really doesn't have any notion of what is the right answer, what is the wrong answer, means that it will inevitably make mistakes. And the systems are getting better and better, but the fundamental nature of that it's probabilistic means that it will sometimes make mistakes. So let me use EU travel compensation as a very concrete example, so we can talk about these things in a very specific way, as opposed to keeping it as a very abstract kind of discussion. So, and again, this is very timely because in India, I think the Indian government doesn't really have well-defined rules for travel compensation. when flights get canceled, arbitrarily, as it's been happening in the last 4 or 5 days. But European Union actually passed in 2004 well-defined rules about what happens if your flight gets canceled or it gets delayed or your baggage is lost and so on and so forth. So they have very, very precise rules. And so that those rules define the logic that the airlines are expected to follow. So we took that application partly because it's an interesting application, but also it helps to illustrate many of the points that I think we want to show, including the role that Predictica's own technology can play in this. So the any agent that you build, and we have built one, and I'll show you examples. And in the last slide in my deck, I give a link to a bot that we have built where you can go play yourself with it and try it out, in real time. When you build an agent using LLMs to solve the travel compensation problem, uh, the agents suffer from three kinds of mistakes. One is missing knowledge. If it doesn't even know the rule, it's not going to tell you I don't know the rule because it doesn't know what it doesn't know. But it'll still try to give an answer, and of course, it'll give the wrong answer. The second problem, which is actually more pernicious, is that even when it has all the rules, it has all the documents, it is not able to follow the logic correctly because, as I said, it's really not a large corpus of data that, in the process of building, coming out with the answer, it ends up in many cases behaving like it's actually reasoning. But it's very clear that's really not reasoning. And when I get to talk about the river crossing puzzle and my white paper on that, you'll see which is the probabilistic nature of how things get done, which means that since it is using simply the probabilistic weights between words, there is no guarantee that it'll come up with the categorically correct answer. So that's on the technology side. On the business side, in 2024 alone, 26 million flyers were delayed by 3 hours or more, and that entitles them to compensation. And it's estimated that about 6 billion euros should have been in compensation, but only 2 billion was paid. Probably would have gone bankrupt by now because they would have been, uh, forced to give, hundreds of thousands of crores in compensation. So it's fortunate that EU-like rules don't apply here. What we have done is that we have used, Practica's own technology to create like a co-pilot that guides the LLM, and we'll talk about that in on the LLM. We use Practica's deterministic logic engine to apply the rules in real time, as an adjunct to the LLM, and correct the LLM when it makes a mistake. And you'll see examples of that. Okay, so let's take a typical query. I flew from San Francisco to Zurich on Swiss Air and then on to Milan, also on Swiss. My flight arrived late by 3 hours at uh, Milan, Italy. Can I claim any compensation? So this is a typical flight situation where the user would want to know, am I entitled to any compensation? Fact-based lookups and also some simple inferences. So it has to convert the cities to ITA code, then extract the country out of the code, and then get the lat long. So that's a more of a database lookup. Then for each city, it has to determine if the city is covered by the EU rules or not, because the EU rules apply to flying from an EU city to a EU city or a non-EU city to a EU city. So when I say San Francisco, it has to figure out what country is San Francisco in. Is that an EU country? Fine. So San Francisco is non-EU. Zurich is in Switzerland. Be covered by the EU rules. That's covered. So that there's a different document that says that. So it has to make some inference along the way to say, okay, we're flying from non-EU to EU, and then Milan is in Italy, which is the EU country, and therefore you're flying from non-EU to EU, right? Uh, So the first column deals with a lot of fact-based lookup. The second column deals with to determine compensation, you have to make lots of logical decisions. Is the delay covered by EU rules? Right? There are rules about if the flight starts from outside of EU on a non-EU airline, then the delay will not be covered. But if the flight starts from outside of EU on an EU airline to an EU city, then if the delay is covered. And that depends on what the airline is. If it's a EU airline, then it's covered. If it's a non-EU airline, then it may not be covered unless you're flying from EU. So anyway, so there are all these kinds of rules and logic that need to be taken into account. Then is the delay at the final destination eligible? And that depends on how much is the delay, and was the delay on the first leg or the second leg. Uh, how much compensation? There are different rules about compensation based on distance, compensation based on which cities were involved, and so on and so forth. So when I talk about business logic, these are all the logical decisions that need to get made. And the answer to these questions are spread over multiple documents, which are all when we examine the various chat programs, chat GPT, 4, 4.0, 5, 5 in particular, we found that all these documents they laid out the initial rules, and then a number of court cases happened where they were kind of gaps in the rules that got tested by someone saying, hey, I had this problem and I got denied compensation, and the court said, no, no, that was covered, or the court said, yeah, that is not covered, and so on. And then UK decided that they want to, even though they are no longer part of EU after Brexit, they will still adopt it. So they they put out a new policy document, and then EU came out with a revised document training set. So when you ask the LLM a question, it is taking the information from all these documents to give an answer. And as I said, because of hallucination and missing knowledge and inability to apply logic, it'll many times do the right answer and other times it'll do the wrong answer. And that's where we need to supplement it to make sure that we can give the right answer to the user in every case. Uh, So the LLMs, as I said, they make hallucinations, they make mistakes, even on facts. So, for example, if you ask the LLM what cities are covered by flight KL606, which is the KLM flight from San Francisco to Amsterdam, what's interesting is that it does not always tell you that the flight is from San Francisco to Amsterdam. It'll sometimes say Los Angeles to Amsterdam, sometimes it'll say Los Angeles to some other city, and so on. So even though it's a very fact-based lookup, it still makes a mistake. And when we dug into it, basically it's because it doesn't really have a notion of what's a fact, what's not a fact. It's actually, even though it has documents that talk about KL606 flew from San Francisco uh, to Milan and arrived 1 hour late or 3 hour late, and it's been on time because it has all these conversations from flight tracker and people's blogs and so on. It's got tons of documents that talk about the flight. It really doesn't know which one is the right answer, which is not. So it takes all of that. The probabilities are based on what things are talked about more often than not. And so maybe the flight from Los Angeles to Amsterdam was talked about more in these blogs than San Francisco, and so it ended up giving the wrong answer. Anyway, so that's one kind of problem. The second problem is missing knowledge, right? I mean, if it doesn't even know about some of these rules, it'll obviously make a mistake. There are techniques like RAG, which is retrieval augmented generation, that have been used to solve this problem. Namely, you say, okay, it doesn't know this document, so I'll feed this document as part of the system prompt, and let the LLM consider the document before it generates the answer. And that can work sometimes if you have a which is the probabilistic nature. Uh, the key thing that we have found is that if the logic is spread across multiple documents, which it is in this case, then even if you give it all the information and it's been trained on it, it'll still make mistake because it's not really able to apply piece the logic correctly across different parts of the document. And of course, the final thing is, can it give an explanation? It actually makes up the explanation itself. The impact of these mistakes on business is obviously pretty far-ranging. The courts have already ruled that if these agents or these programs are fielded by an enterprise, then the quality of the decision is the responsibility of the enterprise. Famous court case where which was helping people decide, and someone basically wanted to take a flight and they had a death in the family, and they said, well, is this flight covered by your bereavement policy in terms of, I think there was if you had a death in the family, and the bot said yes, under a bereavement ticket, and you can apply for a refund when you're done. So this person took the flight, applied for refund, and the refund got denied, with the airline saying, well, that's not a policy anymore. And this person went to court, and the court said, no, if your bot said it's on your website that you will get compensated, then the airline is responsible. So the consequences of the wrong decisions can be, a small monetary fine, or it could be a catastrophic thing. For example, Indigo's flights getting messed up could actually be, and the DGC is already announcing they're going to be investigating. So even though it's a decision not made by an AI agent, the time is not far where these decisions could be made by an agent, and the cost of those mistakes our technology and use that to, and I'm going to start rushing through it because I'm realizing I'm running out of time a little bit. So we basically extracted the logic for the EU compensation as a deterministic logic engine. How Predictica works. Basically, the user input comes in, and it goes logic agent, which passes it to the LLM. The LLM generates a response that our logic validation engine checks to make sure that the response is correct based on the logic that we already built into our engine. If the response is correct, then the response gets sent back to the user. If it is not correct, then we take the response and back to the LLM. So it's basically an internal verification loop that acts as a guardrail. And if the LLM has made a mistake, then it'll be asked to correct the answer, and it'll get revalidated. And so, I'll give you some more details about how our experience has been with how well this works. So coming back to the EU travel compensation problem, let me show some examples. Going back to the example I started with, I flew from San Francisco to Zurich. All of this is GPT-5. We have not tried 5.1. It came back and said you're entitled to. And it gives some explanation because the journey started outside the EU. In the yellow is our logic validation engine looking at the same problem and saying, no, you made a mistake. The correct amount is 300. Please revise. And then it gives a full explanation. The first flight is on EU. The second flight starts and ends in the EU city, and that satisfies Article 3.1 of this document. The total flight distance is over 3,500 kilometers, and the final flight was delayed between 3 to 4 hours. That satisfies this article, and based on that, the compensation only 3 to 4 hours. This whole explanation goes back to the LLM, and then it's able to come up with the right answer. So basically, second. So if you remember the loop, the input from the user goes to the LLM, it produces an answer, then goes to our LVE that checks the answer, and if there's a mistake, then the some guidance information is sent back to the LLM. And notice that it's all happening in natural language. There is no other API being called, and now you get a correct answer. Here's another example. I flew from Frankfurt to Dubai on Emirates, but my flight arrived late by 6 hours. And again, non-EU city on non-EU airline. There's a different. There's one rule which says that if you're flying from any EU city to non-EU city, it doesn't matter what the airline is, you're still entitled to compensation. It kind of didn't apply that rule. It simply applied the rule about a non-EU airline because there are different rules about airline versus cities. So again, our logic validation co-pilot looked at the same situation and said, no, you made a mistake. The compensation is 600 euros, and it gives the right rule and the right reference to the right document. And based on that, then the agent is able to give the right answer. So there are more examples. I'm going to just skip through that. It's all there in the deck. If you're interested, you can go through. In this example, notice that the explanation also changes, but once you give it proper feedback, it actually generates the right answer and the right explanation. Of course, the LLMs don't always make a mistake. So here's a case where we both agreed it's the right answer. Let me quickly go through a river crossing puzzle. It's a good example of a planning problem. By planning problem, I mean the answer is not like in the compensation case. It's a question of I took this trip, I made this trip. Am I entitled to compensation and how much? In a river crossing puzzle, you actually have to take multiple steps, and each step has to be legally. That's an example of a planning problem that it could be travel planning, it could be logistics planning, it could be supply chain. So they all are planning problems, and so this river crossing is and the same idea of basically providing a reasoning co-pilot works, and we built a co-pilot using Predica to solve this kind of problem also for demonstration purposes. So many of you have seen it either on the internet or even before internet. Growing up, we used to love to solve problem. The basic problem is, there's a river with two banks, and a man has to take a goat, a bale of hay, and a tiger across. They can only take one thing at a time, and there are some rules about if the goat and the bale of hay are left alone without the man there, the goat can eat the hay, and if you leave the goat and the tiger there without the man, then the tiger can eat the goat. The man can only take one thing across at a time. So come up with a sequence of steps that this person can carry all the three things from one bank to the other bank without anything being eaten along the way, right? Very simple puzzle, but it's been studied in computer science for a long time as an example of a logic puzzle and how to solve this problem. And of course, it became an interesting problem in the for AI once LLMs and chat. And when we tried, when we asked, we started with the earlier versions of ChatGPT 3.5, 4.0, and so on. We found some of the older ones were making a mistake, but somewhere around ChatGPT 4, um, uh, they were able to solve the original puzzle quite reliably. You could ask it multiple times and it'll still do the right thing. So we said, fine. Part of the reason it can do that is that there are enough documents on the internet that talk about not only the puzzle but solutions. So since it's been trained on all those documents, we actually created a variant of the puzzle, which you call variant November of 2024. So what we did is we added a fourth item called a bucket of meat, which is the property that, of course, the tiger can eat the goat or the meat, or the goat can eat the hay. But if the meat and the hay are together on the same side, then they act as a charm. So the goat cannot eat the hay, and the tiger cannot eat the meat if the meat and the hay are together. So with that variation, when we tried that with the ChatGPT 4.4.0, 4.1.5, we found that they are not actually able to solve this reliably. Most of them are not able to solve it at all. Some of the later ones are able to solve it sometimes, but basically what we showed, and there's a long white paper that's in the last slide. We showed that basically the LLMs are not really doing real reasoning. They're doing more pattern matching because since they've been trained on such a massive amounts of data, they're sometimes able to construct the right answer simply as part of their sentence completion process. But they're making mistakes enough times to really make you realize that they're not proper reasoning machines. But our goal was to not just leave it at that, but also show how you can actually complete that process where you can get them to reliably complete get the right answer even when they make mistakes. So here is the solution that I've given, and again, not that relevant for our discussion. What we found in trying to solve the variant one with LLMs is most LLMs attempt to solve it like the original river crossing puzzle. So that itself is a key tell that they're really not reasoning. They're basically trying to construct an answer based on what they know about, which is the original puzzle. And in many cases, they were simply ignoring the new constraint. The new constraint being, the bucket of meat and the hay protect each other. They're completely ignoring it. And the hallucination was coming in lots of ways. The obvious one was they would even the later LLM like ChatGPT 5 that could sometimes give the right answer would give the wrong answer in a different session. So clearly, the probabilistic nature was the reason why they would sometimes be right and other times be wrong. Uh, Again, this is getting into more technical details of how you take the puzzle and model it, more precisely, so that a deterministic logic engine can actually uh, can solve the same problem as an adjunct. You take the location of the man, goat, hay as variables, and the location can be one of three values. The constraints can be written like this. The English language constraint is if the tiger is left alone with the goat. Then the tiger will eat the goat. And the expression is if man is not equal to the. And remember, all these variables stand for the location of these entities. So if man is not the same location as the tiger, that implies that the tiger cannot be at the same location as the goat, right? It simply says, uh, if the man is not there, then the tiger can eat the goat, and therefore, so the constraints are written as things that should not be done, and you'll see that when you implement the logic, we'll do the negation of that, so that we're looking for violations, and so we can tell the LLM that you made a mistake, so you can go back and fix it. Uh, so here is the implementation in our own language. Again, I leave this as something for you guys to chew on if you're interested. Uh, here is the same constraint about tiger can eat the goat, but written in a way where we're detecting the violation. So basically saying if the location of the man and the tiger is not the same, and the tiger and the goat are the same location, that obviously means that the tiger can eat the goat. So we generate a message saying the tiger and the goat at the location. Are at the location without the man, this is not allowed, please revise the solution. So that text will go back to the LLM, and it then uses that to then revise its answer. And so these rules, these constraints run every time the LLM generates one step, and if they make a mistake, then they're asked to revise. And so by running this repeatedly, we are actually able to get the LLM to generate the right answer. So in summary, what we found year back. So Gemini 3 was not out, but Gemini 2 was out 4.0, which basically and O1, O3, O3 basically became ChatGPT 5, and DeepSeek could reliably solve the problem when guided by the Predictica LVA. But without that, uh, they would not be able to solve the problem reliably. Most are able to solve it within 3 mistakes. So some of the latest ones like O3 would usually not make more than 1 or 2 mistakes. Some of the earlier ones like 4 would make maybe 3 to 5 mistakes. Uh, Interestingly, what we found is some of the older LLMs such as Gemini 1.5 or OpenAI 4 Turbo failed to solve the problem despite being repeatedly told that they're making a mistake. So they could not even take the guidance. So what we found is there's a clear break between some of the earlier ones and some of the later ones, where the later ones would make a mistake but could be guided to the right answer. The earlier ones would make a mistake and you could not even guide them to the right answer. We basically used to give up after 20 failures. We, After 20 times they would not take the feedback, basically give up. So our conclusion is that the LLM and the Predictica act as a generate and test loop, where the LLM is generating an answer and the Predictica is acting as a test, and that feedback goes back to fix it. This is where we found the hallucination to be interesting, that if the LLMs were not hallucinating enough, then they were not able to generate enough possibilities. And so, in a kind of perverse way, hallucination is actually important for them to be able to solve the problems, novel problems, because without hallucination, they would never be able to come up with an answer that, even though it might be lower probability, would actually get to the right answer. Because remember, they're generating probabilities based on what they know. And when you give a novel problem, it is getting into an unknown territory. And therefore, being able to generate a less probabilistically correct answer may be the key to actually solving the problem. Ramifai, I'm at a good break point. Should I use this to kind of stop and just take questions? Hello?
Yes, that is the right thing to do. Very
Okay.
good.
So then let me just quickly go take 1 minute to go. So I have a bunch of slides on agentic commerce, which of course is a hot area. And I
Okay.
talk about all the issues about where the mistakes happen, what the workflow is, and so on, what can be done. So
Okay.
I leave it as an exercise for all of you guys. You'll see that the cost of making mistakes is very high. The slide talks about uh, what is the annual cost of an error that we made, and it runs into billions of dollars. Uh, Here are some resources for more read up for someone who wants to read about. Uh, this is our bot. Anyone can just click on this link and try the bot. You can see some examples. Here are some white papers about where is HI and LLM, LLM guided logic engine, some of our patents, and so on. So in case someone wants to follow up. There are more slides about we have looked at credit card benefits problem, which again involves a lot of business logic and how the LLM make mistake. And
Mhm.
I'll leave that as an exercise for all of you to go through if you're interested. Um, I think
Now,
I'll stop here.
Thank you so much. This is good actually, and we will go through this exercise. And following your session, actually, I'm going to have have the students actually work on some of the developing some of the agents, and this your presentation very rightfully fits into that plan which we had today. So thank you. This is very good. And students, if any question you have, you can Professor Mahmood. If anybody has any question, please unmute them or.
If anyone have any question, then raise your hand. I will unmute you. Or just you can type in chat box.
So, Dr. Mittal, so if the students, you have given a lot of these links, if students go through that link and try to address that, that will be a good exercise for them. Right?
Sure. Yeah.
Okay.
I mean, don't I mean, look. The white papers that we have, uh,
Yes.
did a lot of very detailed analysis where we took the bots, different chatbot programs. We basically looked at Google, uh, OpenAI, and DeepSeek. We didn't look at Anthropic and so on, but similar things will happen. And we did detailed multiple session studies on how they perform and so on. So I think reading that would be interesting for someone who really wants a deeper dive into this. The EU travel bot is a good one because it's a running bot. You can just apply. You can just click on the link and
Mm.
try your own trip and see what happens. Uh, you can play with what explanation it generates. Keep in mind that the explanation that the bot generate uh, are subject to the same hallucination problem that happens for when
I,
you actually generate an answer. I mean, what we found, especially with the Gemini 2 and O3, which used to have very detailed explanation traces, which they've turned off now, but they were available when we tried them last year, is that their explanations are fraught with the same hallucination. Namely, they would make the decision one way, and when you ask them to explain it, they would explain it in a very different way that had no bearing on how they're actually doing it. So I would take the explanation generated by these LLMs with a big lump of salt. Uh,
mm. Okay.
but yeah.
Okay. Good. Good. All right. This was very timely actually for in the series of classes which we are having. So thank you so much. All right. Let's see. Actually, this is so new for the students. They
No,
are all scratching their head, trying to find
I
out what to ask.
right. I understand. I think what's happening is that uh, much of what the agents are doing today are very simple, repetitive tasks, right?
Yeah.
So they are not even getting into, looking at any kind of reasoning issues yet.
Yeah.
That's the reason we built a whole EU travel compensation bot, so we could demonstrate this. So I realize that
So,
we are a little bit at the bleeding edge, but
yeah.
um,
No, that's good. So, Dr. Mittal, one of the student asked that what entrepreneurship has to do with this flight getting late? That is a good question, actually. So, can you address that, please?
So, okay, I'll give a flip answer. I'll give a real answer, right?
Yeah.
Flip answer is, of course, if you're an entrepreneur and you're trying to make a trip someplace and your flight gets delayed, you won't get there, right? So that's the flip answer. Uh, the real answer is that if you think of EU travel compensation as a business problem, then there are companies in Europe that actually charge you money to answer this question, right? So this is actually a legitimate business problem. As I said, there is up to $6 billion worth of compensation that should have been paid, and only two was paid. So there's 4 billion left on the table, and you can build a company that charges 10% of the compensation that the user is due, and 10% of the 4 billion left on the table is going to give you 400 million, right?
Hmm.
So 400 million as a TAM is a pretty good amount to target to build a company, right?
Right. Right. Yeah.
So my interest in doing this, of course, is not to solve the EU compensation problem per se, but to demonstrate that, look, if you're going to build AI agent that reason uh, and they're going to make mistakes, then how can they fix that? And so we have built technology to fix the reasoning failures, and we use the EU travel just as a demonstration of how that is being done.
Hmm. Okay. Thank you. Professor Mahmood, uh, Professor Mahmood, Professor Suresh Roy is online, but he's on the he's because he's in the car, so his audio is on. And say he would like you to unmute him so that he has
Sir,
some.
his name I couldn't find in the list, sir.
Oh, I see. Okay, all right. Okay. All right.
Maybe he may join from other name. That's why I couldn't find him.
No, no. Okay, that's fine. That's okay. All right. Okay. Dr. Mahmood, do you have any question for your students?
Sir, actually, this is a very new topic for us, and I've requested our student to ask any question, but I think one Hannah. Okay, Hannah, take 1 second, sir.
Yeah. Hmm.
Sir, Suresh Roy, sir, S iPhone.
Yes.
Yes, yes, I'm online. Thank
Okay,
you.
okay, sir. I have made you, sir, co-host now.
Okay.
Thank you.
Uh, Yeah, Professor Suresh, we just, Dr. Sanjay Mittal, he actually just concluded his talk, and you were listening to part of it. So, do you have any comment do you want to share?
It was so interesting that I was traveling from Dublin to Sacramento, and throughout I was just listening to him and how the time passed. It was so interesting. And and Sanjay, I wish you could also develop some algorithm for stocks and bonds and all that, so that people can benefit from this.
So, Suresh, it's interesting. There's an article that I read a couple of weeks back. I'll see if I can find it and send it to you. So, a lot of work has been done in applying AI, algorithms, mathematics, and so on to predicting stock market tracking. Uh, some of the early players were very successful. They built billion-dollar businesses. What's happened is that so much work has been done that it's become almost like a perfect information ecosystem where the edge that you can find is disappearing, right? Because
Correct.
everyone is doing the same thing. So, if there are any, remember, the theory has always been for the stock market that in a perfect information world, there'll be no advantage that anyone can get, right? And so people were applying technology to discover kind of missing knowledge, or you discover some pattern that didn't exist that others had not, and you exploited that. So what the article is saying is that most of these kind of hidden patterns have all been exploited, and there is kind of very little room left to discover more of this, which is not to say they may not exist, but they're getting harder and harder to find because it's becoming
Got it. Got it. Got it.
more
Thank
of a
you.
corporate information ecosystem.
Thank you, Sanjay. Thank you very much.
So what I'm thinking, what I will do is I will get these slides translated and actually go over with the students and try to address some of the questions which they will have at that time. And so I think that will be very helpful. But I will be reaching out to you, Dr. Mittal.
Sir, I
That
have a question, sir.
yes, go ahead.
Sir, what skill should a student learn to design or work with AI agent that follow business logic?
What should the student learn?
Yeah, what skills?
Good question. I think they need to. So one of the challenges is in the application that you're doing, you have to first learn how to find problems, right? It's almost like you have to be a bit of a detective, right? So when we started looking at the EU travel problem, we actually didn't know that the LLM will make mistakes, right? I mean, one of my colleagues had actually said, "Hey, take a look at this problem." We had looked at this a little bit. So I looked at that, and of course, since I've been dealing with reasoning business problem for a long time, I started this type, and I traveled to Europe quite a bit from USA. So I started by typing some of my examples, and very quickly I discovered that actually LLMs are making mistake, right? So anyone, what I would encourage your students to do is pick a domain and play with the LLM to see does it actually give the right answer or not. And if it does not, they'll begin to give you some clues on what might be going on, and of course then what techniques you need to in this talk I talked about missing knowledge and factual knowledge and inability to. So when you look at the kind of problems, you'll slowly you begin to find out what is causing those issues, and then you have to find an answer or a fix based on what's causing the problem.
So maybe Professor Mahmood, I would say that see how like the flight gets late, what
Yes.
compensation you can get, right?
So,
So
Ramesh,
that
here's
information,
sorry to interrupt you. Here's an
let,
example. Here's something I can suggest. You know,
okay.
take an example of something that people interact with the government in Jharkhand quite a bit. I don't know what the problem might be. It might be
Mhm.
about the prices that government pays for different food items or benefit that pick something that has a very wide application and see how well the LLMs are doing in responding to those questions, right? So do it by a real business problem
Yeah.
because in India people are dealing with the government, the state government, the local government, the federal government on dozens of these issues, and they all involve business logic that someone somewhere, a collector, tehsildar, you know, bank
That's
office
right.
is dealing with. So pick a real problem and see how far you can push the LLM to give the right answer,
Yeah.
and what logic you need to capture to make sure that you can actually get to the right answer.
So I'll say like what I was going to say that look at the world today. Yeah, it is going into the exponential growth, exponentially doing it. So this LLM or this agent which you will build, whoever is building, is going to do the work much faster. So you are keeping up with the pace of this exponential growth that which is fueling the economy. So I think that's the biggest advantage I can see, that your answer is you can get the answer so fast.
You can get the answer fast. You can get the answer without it being corrupted by someone asking for a bribe, right?
Yeah,
It can
right.
it is and it is correct, right? So fast wrong answer actually worse than slow wrong answer, right?
Yeah.
So you want them to be fast, you want them to be correct, and you want them to be free of corrupting influence,
Yep, that's right.
right?
Yeah.
So if you
Sanjay, I can suggest one thing. You know, for example, the pension for the senior citizens, that has always been a questionable thing. And every time they have to struggle to get the final numbers. So maybe that might be a good idea to write
sure.
write certain thing about it.
Pick something that has wide applicability. And in fact, that might be a good way to kind of organize a project where, you
Yeah.
get students to say, okay, and the first step would be take the latest LLM. And I think there are some being built in India. But, I think the ChatGPT you can take the regulation that are there, add them as a system prompt, and now it has access to that information, and then see how far you can push it. And then
Yeah.
once you see where it is failing, then we can talk about how you can supplement that either with a predictive style or some other way of bringing a deterministic logic copilot. And you would have a solution that is both an AI agent and fast and correct.
Right. And the second thing that really comes to my mind is, Sanjay, for example, we have here title insurance companies, and there are very few in India. So all the properties, if it can be transferred to some sort of a logic where we have the right title to a house or to a property, and without any liens or anything associated with that.
Mhm.
Right. I think the problem with the title problem is that you're going to run into missing information issues, right? The problem with the title is, I mean, from my naive understanding, is not that there's a logic involved, but the property was 30 years back, someone had put a lien on it or made a claim on it, and that person is no longer there, and then how to adjudicate those kinds of issues. So I would feel the title might be a very messy problem, whereas pension is probably much easier, right? There is service rules that how many years you worked, where you worked, and all other kind of stuff. So it might be much easier. There's probably well-defined rules about who gets paid how much based on years of service and what role they were in and all that kind of stuff, right?
Mm, got it. Got it. Thank you.
Pension may be a good area.
One question has asked by some student in chat box.
Yes, please.
What kind of challenges we can face if we have an idea in already immersed sector and want to use AI agent like tiffin service in Mumbai or handcraft in Jharkhand?
So, I'm sorry, what is the application? A tiffin service.
Yes, a tiffin service or a handcraft business in Jharkhand.
So, remember, my talk was focused very more narrowly on business logic reasoning failures, right? Now, when you're building an agent for, let's say, tiffin service, there are a lot of routine tasks that you have to do successfully. I didn't address everything, right? Uh, so to do tiffin service, you obviously have to automate the whole process of someone making a request and the request being sent to for fulfillment and tracking the shipment and all that kind of stuff, right? So all of that work still needs to be done. That is not necessarily a business logic issue, right? So I don't want to make it look like this is all you have to do to build an agent. There's a lot of other things you have to do. I was talking about the agents in many cases will have to do some reasoning around business logic, business rules, regulations, and that is where the failure that the LLMs, the mistake that LLM make become a serious issue. And how do you solve that? So I'm talking about one specific niche, and a very important niche, but very specific niche, in building agents.
Okay. If there's no other question, then I really want to thank Dr. Sanjay Mittal for such an insightful and such a path to where we can learn, where we can go the next step in this phase of learning about this AI agents and all these models. So thank you so much, and I truly appreciate on behalf of the Jharkhand University, BIT Sindri, Dr. Prakash Kumar, K. Singh. They have personally told me to thank you, Dr. Mittal, and we really, really appreciate that. We appreciate your time. We appreciate that you really took that extra step to give that knowledge to our students. Thank you so much.
Thank you, Ramesh Bhai, and thank you everyone at Jharkhand. Thank you, Suresh. And
Thank you, sir.
okay, take care, everyone. Bye.
Thank you.
Thank you, Sanjay. Good night to you.
Good night. Thank you so much, students. And what I will do, what I plan to do is that जो इनके जो इन्होंने जो presentation दिया है, maybe some of us, maybe I can have a team together और इसको हम लोग हिंदी में translate कर दें. So if you are interested in being part of the team, so it will be a project for all of us that we want to convert this presentation into Hindi so that the students in the not only at the BTech but also